So, yeah. So good afternoon, everyone, and let's kick off this section. It's about the DAX, and this session will be DAX the way to do it. It's just I try to make it a little bit funny about the name because I think that we really want to get things done, and DAX can be our best friend if we can leverage it to our well-being. So let me tell you guys a little bit about me. So thanks also for the introduction. Exactly as said, I'm a team leader at Natixis. It's part of BPCE, one of the largest banks in Europe. I work with business intelligence teams, with big data and software development teams too. I came a little bit from the business background, so I was more of a business user, like a manager. Then I worked my way. I really enjoyed to work with business analytics, so I worked as business analyst. Then I went even further in the technical side, working as a BI solutions architect, as a consultant, and I also lectured some courses in BI2 at university level. And I'm the co-founder and the leader of the Portugal Power BI meetup group. We do regular meetups every month, and we love to share with the community. And we have both Portuguese as well as international guests in our meetups. And wherever I can, I try to attend and to be present in technical events. I really believe so strongly about the direction that Power BI and Power Platform is going. I think it's a sure bet to bet on these technologies for our future. So I absolutely love working on it. So the introduction about our session today. So I wanted to share with you guys about what is DAX, and DAX is it means data analysis and expressions. It's basically one of the languages beside the Power BI. You have DAX, you have M2, and DAX means the language behind Power BI and Power Pivot regarding doing analysis expressions and queries. And so it exists in Power BI, it exists in analysis services, Tabular, and it's awesome. What it can do for you guys? You can do a lot of things. For my experience, two main use cases. If you are a business user or an analyst, I think it can be really helpful for you guys because you can control more as a subject matter expert. You can control the business logic on your end. Or if you, on the other hand, if you are IT or BI, you can leave the logic to the subject matter expert, and you can control it more on the terms of the performance, the good modeling, the respect for the entities. So I think this should be also very good, and these two together should know about the features of DAX and what it can do for you in the way that it can leave the work, focus on what is more important on each of the sides, and they'll leave the rest to the other one. So who is this session for? This session focuses mostly for the beginner and intermediate level, because I believe if you are already an advanced user, you know where to get the information, you know where to search it, and you surely know a lot about DAX already. So I hope that more in the beginner and intermediate level, I think that this section will be able to give you some good ideas and some pointers to continue your development about DAX. So let's talk about the core of DAX. So I like to ask what is this that we have here, and the normal answer is that this is a table. It looks like a table, it feels like a table, it really, well, in reality is a table, but in terms of DAX, what we can say is that this is a visual representation under a table visual of an expression evaluated in a context modified by filters. What this means, so the expression is total sales, and it's the representation under the table visual here of this expression in a context modified by filters, and the filters are here. For instance, that the state is the filter. And I will explain you why I want to precise this. This will help you understand about DAX. The way to understand DAX is looking at each, let's take a look at this cell. How does this value appear here in the screen? The way to understand this is thinking about each cell as an individual calculation and an evaluation. So this value here, the expression is the total sales, and the context has been modified by filters like the state is Colorado, the year 2015, and even the employee. All these are changing the context of our expression, and it's being displayed here. And if it is in another cell, it's the same thing. So it's just a different context that is being applied to the value displayed in this cell here. So you need to also understand that the filters can come from multiple places. So for instance, here it comes from the rows of a visual, it comes from the columns of a visual, it can come from another visual when you click and cross highlight it, it can come from the filter pane, it can come from multiple places. It's the same, basically, it affects the same way the evaluation. Other thing important to understand too is that the filters can come from different tables. So what this means is that let's take the example that you need to understand what is an expanded table. So if you drag fields from the sales table, if you then drag fields from the date table, from the employee and from the geography, behind the scenes, it's like doing a massive join in SQL. You get an expanded table with all the fields, like a huge view with all the joins. So let's take an example. If you drag some an expression which is the total sales, which is just the sum of a column, and then you drag a filter from the year, you drag the column year and put it a filter equal to 2018, your expanded table in reality is this one with sales and date, and it's like going to Excel and applying a filter that the year is 2018. So if you do another selection and even another one like the year, the employee, the state, is the same thing. So you are doing expanded table, you are expanding your table and then applying different filters. So this is the way that it works in Power BI. And then your expression, now this total sales, is only evaluated in the new context with the filters applied. So we are going to talk about two concepts, about the concept of filter context and the concept of row context. And these two are quite different. And you need to understand them, and also when there is a transition from one to the other. So the first one is when we talk about filter context, all this here, if it's in the row of a table visual, or if it's in the columns, or if it is like in a filter pane, it doesn't matter. All these are filter context. And when it's this here, it's in the rows, but this is not row context. Don't confuse it. This is just any other place, because I can just pick this Colorado and put it here in the columns, and I can pick this one and put it here in the rows. It produces the same effect. It changes the context for your cell in the same way. So all this is filter context. When we talk about row context, it's like when you go to the data view of your model in Power BI desktop, and you see really the rows row by row. These are rows. This is row context. So this is the main difference between the two, and I'll give you guys some examples to illustrate the difference. So let's talk about also another important concept, which is the return types of DAX. The first thing is that there is one return type that can be brought that is returning a table when you do a DAX expression, or it can return a scalar. Just these two, table or scalar. And some functions that can return a table are functions like filter, all except, all selected, etc. And functions that return a scalar value are some of them are like sum, mean, max, count. All these just return a simple scalar value. And the best place to learn, I recommend, is the DAX guide from SQL BI, because it has even better documentation than the Microsoft documentation. It has the examples about the functions, but it also explains about which of the versions of each of the software work for each function. So let's say you want to know about calculate table, it will tell you if it works in a analysis services 2017, 2019, Power BI desktop, for report server, whatever. So it will help you understand that. So let's start talking about some functions in DAX. So one of the functions in DAX is calculate, and it's really the most unique and powerful DAX function. And what calculate does is evaluates an expression in a context modified by filters. And so what this does is that my expression is my total sales, and calculate is doing the evaluation of this expression, and the context modified by filters is that here I'm changing the context from my state and putting that it is from Texas. So let me give an example here. So if I want to do a calculation like this, like total sales taxes, I have, and just to display the value of taxes for each, for the rows where I have taxes and not display anything for the other states. So there are a couple of considerations in regards of this. I will show you directly. I will not discuss too much here, but I will show you directly in the demo how it works. So our program for today, I want to show you guys not too much boring PowerPoint and not too much theory, but to go in more detail into demos for you guys, row and filter context, manipulating tables and scalars, time intelligence, rankings, text manipulation, header detail tables, security with DAX. So I will try, I have many demos, I have 8 demos. I will try to show you guys 4 or 5 of the demos in the time that we have. And let the fun begin. You guys will not, important disclaimer, you guys will not learn DAX in 40 minutes. This is a language that requires not only looking, but to really practice. But the best thing is that awareness is great. I'm sure you guys can do the rest. If you really see something that is possible, you just know about the possibilities, you guys can find the information. Then it's very easy today. With the product direction of Microsoft Power BI, you can find information anywhere. You have communities. So if you know what you're looking for, you will find the answers, and you will also find people to help you. So awareness is great. You can do the rest and practice, practice, practice. So let's go to the demos, which is really what we are here for, right? So I brought here a couple of demos for you guys. Let's start with the first demo. I'll get some water just to get prepared to hit you guys with the demos. And this first one is the one which is more conceptual and important to understand some of the key concepts in DAX. So I will increase here our pen a little bit. We have here, let's take a look at the model. It's one of the most simple models that we can have. We have like a sales table, a factual, and then you have some dimensions like a calendar, a geography, and the employee, and all these will filter directly and revert into the sales factual table. So what we can do here, I want to illustrate this case in which I want to do a measure. I have a total sales measure. Let's take a look at the formula. So I have it here. And my total sales is just something very basic, which is the sum of a single column, which is my total including tax. So what I want to do now is a total sales just for taxes, and I will try to do it in a way which is what I call with a direct calculate. So I apply a function calculate. I can reuse now an existing expression or give it a new one. If you can, always use an existing expression, so total sales, and then you can change the context modified by filters. So what I'm going to do is hard code that the state will be equal to taxes. Let's see what it does and what happens. So our output is obviously that the result will be the same for each of the rows, because we are changing the context. We are saying, oh, you have Colorado here, please remove it and hard code that the geography is Texas. So this is why the value that we have here in Texas will be shown on each of the rows. So let's do it in another way. I will do another calculate, my expression, my total sales, and I will modify the context again. I will use a filter function, which is give me a table and modify the context of in the filter of this table. The table will be all my geography, my entire geography dimension, and when I put an all, it means that I will unfilter it, remove all filters that are there, and then I will apply it another expression, which is that the state is equal to taxes. I will copy this because I will need to adjust it in a minute. So when I apply this, what will happen? It happens that I receive exactly the same result as I have here. It's the same thing. This is the same thing because in actual the two functions are identical. So behind the scenes, this function here is just a simplified notation that Microsoft allowed for you guys to be simpler to come from the Excel world and start getting your hands on Power BI. And this one is actually what it happened behind the scenes. So we are doing a calculation of total sales, and that other function translated into doing a filter function, unfiltering your geography, and hard coding a filter that it's equal to taxes. So if I want to obtain that output like I shown in the PowerPoint, what I can do is doing this calculate, but instead of using a null, what I can do is just say keep any field, keep the geography table as it comes, wherever filters can come from other places, and apply it a further filter in which the geography state is equal to Texas. And with this, I can have the result and the output that I expect correctly for my Texas cell, because if, for instance, in this cell here, I have a context that comes from California, which is applied here, and then I'm hard coding another context from Texas here. So the two together cannot be true, so it returns a null. While in this one here, I have a context from Texas and a second context from Texas from the expression, and it returns me the value. So this is the first demo for you guys to understand what calculate does behind the scenes. The part 2 of this demo is that I want to show you guys the power of time intelligence in DAX. And there are a couple of scenarios which are very common in all of the industries, which is you have sales, of course, all these businesses need to sell, and then you need to compare how is your performance in sales versus, usually versus two things, the previous year, or the comparative period, and also how you are doing this year or versus your budget. So you compare it versus the previous year or some period, and also you compare it versus the budget. These are the typical cases. We'll do the exercise regarding the homologous period. So I have here my total sales function, and I will do a calculation of this total sales function, in which I will do a calculate. I will recall my existing expression total sales, and I will modify the context. I will do a date add, and the dates will be my date column, and I will shift it -1, and I can shift it month, year, whatever. I will shift it 1 month backwards. So let's see if this is working. I have here in my January 4677 3990. And in my January 2014 and February, I have the same values. So my total sales from the previous year correctly gives me back the values of my total sales of the previous year. So far so good with a very simple function. What I'll do now is another thing which is very common, which is to do year to date. And you have a function time intelligence, which is total year to date. The expression is always also the total sales, and your dates is just pointing to the date table. You don't need anything else. It's as simple as this. And you will see the magic happening with the DAX. So you will see January and February data here. Sorry, not this one. The January, February, and for instance, here, the February value of 2015 is equal to the sum of my January and February months. Or my value here, 13, is equal to the sum of my January, February, March values here. The three of them joined together will give me my 13 million here. So it's working fine. And finally, you can do the same thing. I want to compare my year to date versus how it was my year to date on the same period last year. So I can do another calculate. I can recall and reuse my existing expression, my year to date total sales. And I will shift the period back. I can do a date add like I did before, or I can use another function. I will show just for you guys to have a different example. Same period last year of my dates. I will shift back. This is exactly the same thing as doing date add -1 year. This same period last year does exactly that for you. And so we can also verify that here, these values here match as I have them here. So it's correctly reverting, as we expect. And now a very common case is also to do the variation in absolute or in percentage. I will do the percentage variation. I will divide the year to date of this year and the year to date of my previous year as the numerator. Give it 0 in case I run into a division by 0, so that it doesn't return an error, and subtract 1 so that I get the percentage correctly displayed. And now I can change all the filters that I have in my model. I can apply different filters, and everything is dynamic and calculating my year to date as I expected. So you see here, I even have a function here which shows me the dates that are selected. It's something like report dates. it gives me the first date, it concatenates report data from, and my first date and my last date according to my selections that I have here. So this is the end of our first demo with the calculate, filter, and context. So I will pick here another demo. I want to show you guys another demo that for me is very interesting, which is I have here, let me open it up also this model. And I have here a sales factual table, and I have a product dimension, but these product dimension are in what we call a snowflake schema. So we have the hierarchy, which means product, and then you have the higher hierarchy subcategory, and then the higher hierarchy product category. And my challenge here is that I want to count how many categories have over 200 products. This is particularly relevant if you work like in retails or in an e-commerce context, in which the assortment is a key driver towards the traffic that you get for your site. It's a key decision element for customers to pick your site. And if you want to track the assortment in each of your categories or subcategories, it's something that you should do. And so how can we calculate this with the DAX? So I need to create like a KPI here, which tracks this according to all the categories that are shown here, how many have a certain level of assortment, or I could create buckets, I can do a lot of things. So I need to return here a scalar value, but I need to manipulate the table before returning this scalar value. So maybe if I do directly in a formula, it will be too complicated to do it. So the usual way that I do it in two ways. I go to DAX Studio and do the same thing. We can also do here within Power BI, which I will do it just to be simpler to understand, which is I'm going to create a new temporary table just to illustrate how the calculation works. And I'll put that my table 1, which is just an auxiliary table, will be equal to, and I will use a function which is called summarize columns. This is basically the same as a group by in SQL. And so what this summarize column does is I can type columns from different tables, not just from one table, and it will do an automatic group by according to the relationships that exists. So I want, of course, my category, my product category. And then I want to have a number of rows KPI. I'll give it a name. And which is the expression? Is the count rows of my product table. Close brackets. Always try to keep your code, DAX code formatted. So here I have just a summary, like a distinct of all my categories and the number of rows that they have. So this is returning a table. This DAX expression returns a table. So let's keep returning a table, but I will further apply a filter function, which is go to this table and filter it. And now I can reference this column that I created here. I can reference it, and I can say that the number of rows, you see here, it appears. I can reference it. Number of rows must be greater or equal than 200. And I close it. And you see, this is returning me a table. So I will copy it. Now I have what I need, and I just need to count how many rows I have here, which is 5, obviously. So if I plug it in here, if I plug the function here, if I will put here, just to show you guys, if I place this formula here, it will return an error because it's returning a table and not a scalar value, which cannot be. So what I can do is I count rows, and now it asks me the table. I give it a table, and then I close parentheses. So you see, this is the interesting part about DAX. You can nest functions that give you a scalar with functions that give you a table in DAX. You just need to be aware of what is going behind the scenes. This is why I did a step-by-step for you guys to really understand what happens behind the scenes. And now, according to any filter that I am able to put here, so if I pick just something like this, low, mid, you see here, now I just have two categories with over 200 products if I pick just one stock type. So this KPI is completely dynamic, and even further, if I apply different filters, it will continue. This KPI will continue to be dynamic, which is quite interesting. So another thing that it's very powerful to do in DAX is the rankings. I have here two examples, which is you can do very simply a ranking of your brands according to a KPI. It could be the sales quantity, it could be any other KPI. And you can show this ranking for all the products. So you are unfiltering your brand column and you are making all of them available to be ranked. Or you can do almost the same thing, but instead of all, just with all selected, so that it does the brands, the ranking of the brands that are selected. Let's try it out. Brands, so we can see this one is number 1 in my selection, but second overall globally, number 2 in my selection, but 7th globally, and so on. So very easy and also very interesting for the users, and we can do some conditional formatting, etc. It's quite powerful tool. We can also do text manipulation, something like this, where you pick a couple of categories and you display something like this. You have desktop, cell phones, computer accessories, and 3 other categories. It's something that's also possible with DAX with some text manipulation. For this, what we use is, I'll give the first example, is a function like, we use a function which is concatenate x, in which you concatenate all the values that are in this subcategory column within the product subcategory table, and I pick a delimiter. This is a step 1. My second step is I do a top 3 of my categories that are selected. Oh, it's okay. And I put in a descending order. And I also concatenate after I have just a table with 3. This returns me a table with 3 values. And then I do the concatenation of the values on that table. And finally, I use the output of that function that I just used, the selected subcategories top 3, and I do a variable which is counting how many rows I have selected in the subcategory. So I have here 6. This will return 6. We could do something like if I put return number of rows. This is interesting also to control with DAX variables. What will it return? So I can control, this is something why I recommend using variables. You can return the intermediate steps as you work your DAX code. So you see, it was returning 6 categories. And so if your 6 is greater than 3, then you will concatenate the categories that you have here from the previous KPI with how many rows minus 3, and you finalize the sentence with other categories. So you get this effect, and 3 or 4 or whatever, desktop, cell phones, something like that, and 5 other categories. So you can do a lot of things with DAX with this. You can put, for instance, when you show on a map, you can put showing Portugal, Spain, and 3 other countries, things like that. The possibilities are really endless about it. So this is the end of other of our demos. I will go on. Okay. So this is more challenging already and a little bit more advanced. So what are we going to do here? I have a model which has orders. It has items. So each of the orders has multiple items. Each of the items has a product corresponding, and each of the products has a specific size. If I go to the size table, I have just 3 sizes, which is a small, medium, and large of my items. And so my challenge here is I want to represent the largest size an item in an order. So if the order has like a fridge and an accessory, I want to show that the order is large because it has a large and a small item, and I want to show it as large, which is the case here of my order number 2. It has a large and a small item. I want to have large here and here. So how can we do this? First, let's talk a little bit more about row context. So here in the row context, it's important also to understand some things, which is In my orders, I don't have any value yet calculated. And at my items level, I actually have here, let's say that my order number 1, I have here one order with one item at 10 and two items at 12. So I have 10 and 24, and the value of my total order will be 34. Okay. What can we do here? What I want to first do is the calculation of my order value, but as a measure. So calculate it here as a measure. So let me calculate it. So I'll do an expression which is an iteration. I will do a sum-x. I will iterate my items table, and I will calculate an expression which is quantity multiplied by price. Exactly the same thing as a sum product in Excel. So I see that the value is correct. So for my order number 1, it has for the item type number 1 and for the item type number 2, a 10 and 24. If I do the exactly same calculation at the order level here, but as a calculated column, so if I copy paste this expression, what will it happen? It will happen that the value will be the total of all my item sales. And why is that? It's because this context here from these rows is not passed from the order table to the items table because there isn't anything here to pass the context. Well, you can force this passage of context with a calculate. It will force that this filter from the order to pass to the lower granularity, or instead, what we can do, I'll copy this again. I'll do the same thing, but instead in saying that I'm doing a sum-x in my items table, I'll do a sum-x, but saying that I'm working on my related table items, which is I'm specifying that this table is I'm working on the one side, and I want this calculation to be done on the n side of a one-to-n side relationship. And now it's correctly being calculated. So let's go back to the report. And what is interesting is that we did almost the same calculation in 3 ways, with a measure, with a calculated column without related, and with a calculated column with related, and the results are completely different. So you see here, it almost looks like the same, but the results are quite different, and you need to understand this to understand how to manipulate your data. So coming to, after having the value correctly calculated, I also want to show you guys how to fix that problem about the item size. So first thing, I'm going to calculate here an auxiliary column at the item level, which is item size ID will be equal, and instead of a related table, now I'll do a related, which is I'm going from the one side to the from the n side to the one side, and I'm going to do a lookup. And this lookup, I will get the item, the ID of my product size ID. So let's see what this is doing. So I have the size ID here, but I also have it, of course, as this is, I have it here in my product. So each of the product has the specific size ID. And what I'm going to do, I'm going to bring it here and add it as a column here temporarily. And then I'm going from this table to iterate all the records that I have here from the size IDs to get the largest one. Let's say this is an order, and I want to return the largest one here to my orders. So let's try to do this one now. So I'll try to iterate and get this order size. So my order size, I'm going to use another function which is an iterator, which is a max x. And the iteration that I want to do is I'm going to iterate my table, which is the items. Correctly format this. I will iterate items, actually not items, my related table items, so that we don't have that problem that we just seen before. And the expression I'm going to iterate is my item, what was the name that I just gave it? Something ID. Yeah, items, item size ID. So I'll iterate this column, and I'll get the maximum under each of the orders. So for this order, For these two items, I'll get the largest one. For these two items in order 2, I'll get the largest one, which is 3. I wouldn't even need this. I can do directly a related here ID of the product size ID. So imagine how crazy this is. I'm doing just in one step a calculation, which I'm iterating another table. Not this one, products. It's not the products. Related products, I think it's this one. Products. Give me a second, I'll get it here because I forgot. Yeah, it's this one here. Okay, so imagine how crazy this is. And now what I want is to translate this into the actual order size. So what I'll do a lookup value. This is exactly as the name says, it's a lookup. So I want to return the size. I want to search for the size ID, and I want to search it in this expression that we just seen and just calculated. And this will do the translation of this number to the actual size. So I will get it here, and now I have my order size. I can test it. Why doing it in a calculated column and not in a measure? It's because now you can change it as a slicer, and you can filter. I want to see how many large orders I have, in which are the items. So here you have it. If I don't need now the item ID, so you guys see here, I don't need now the size of the items. So each of my orders is correctly calculated. And I see which are the orders which have each of the sizes. So here I have the problem solved at the order level. So this is the end of our demo number 5. I will go back to our PowerPoint. So to wrap things up a little bit, sometimes it's not you, it's your data model. What I mean by this is don't try to patch things up with like some crazy DAX formula, very complicated. Maybe normally the problem when I see, many times it happened, people would come to me and ask me, hey Pedro, can you help me with this DAX formula? The problem would not be the DAX formula, would be the model. Because the entities were not well respected, and then the DAX formulas would of course be very difficult if you don't respect the granularity, the relationships. So usually, honestly, my code in DAX is usually very simple, and I work the model, and then the DAX is intuitive and works really well. Also, if it's not formatted, it's not DAX. It's important to keep your code very well formatted, and I try to do this with Shift-Enter and to indent your code. Some resources for you guys also to learn. You have SQLBI.com, which is the reference site, and all the materials associated from it. So SQLBI, you have the book from the SQLBI guys, the definitive guide to DAX. You have DAX Studio, which you can do it to improve performance when debugging your DAX code, or you can do the new performance analyzer within Power BI Desktop tool. You have the two options. DAX Guide is the place to find the functions of DAX. DAX Patterns is a very interesting site which you have pre-made blocks of DAX code for some very common use cases. Like let's say you want to do ABC segmentation, you have already pre-made blocks of DAX that you can find there. And the same thing, you have the custom visuals gallery in Power BI, but you also have one thing. If you Google it, quick measures gallery, it has also some user-made DAX expressions like we have here, but made by each of the users and published live. And last but not least, a new site that just came out like 2 or 3 days ago, DAX.to from SQLBI. This is the site. It's basically a tool where you can try out in a browser live DAX and see how it works. So you can do something like evaluate the currency, and you will run the line, and it will display the output of your DAX code. For now, there is I think only one dataset there, which is the Contoso sample dataset. But in the future, I think that from the guys from SQLBI, there will be more developments there. So I think this looks really quite promising for the future. I'll definitely, in the next Power BI Portugal meetup, there will be Marco Russo and Alberto Ferreira. They will be there, and I'll definitely talk. It will be in English, and I'll definitely talk with them about this new tool. It looks really, really awesome. So to thank to the datasets and the reference material to sqlbi.com, this is my blog, https leadingwithdata.net. If you guys want to get in touch with me, drop by, check it out, my blog. Or you have all my contacts here, my LinkedIn, my email, and the link for my blog. I hope that you guys enjoyed this session, and we have, I think, a few minutes also for some questions you guys might have. So thank you very much for having me today here.
Thank you, Pedro. Deepak, do we have any question? I know there was a list of questions that came up. So
I see a question here if these syntaxes apply in Power Pivot 2. Exactly. So DAX was born first in Power Pivot 2. You have your DAX code will work in there, but the thing is that the interface is much more limited than in Power BI and with the IntelliSense and things like that. Honestly, I don't know how to write DAX code without IntelliSense with the autocomplete. It's almost impossible to do it.
And then there is another question.
I see Celia here from Portugal. Hi, Celia. Nice for you to be here. Thank you.
Yes, Celia was a presenter first session in Power BI track. She presented today morning. So I don't see any question that. So there is a question. Do you share PPT demo? We are not asking this to presenter. Session is recorded, but Pedro, can you answer to that question?
Yeah, sure. So on this, usually I have many different demos. According to the time I present, sometimes a few or another ones. I have here a package with the demos or with the PPT for any of you guys that is interesting. So just send me an email or reach me through any of these channels in LinkedIn, and I'm happy to share with you the contents of the presentation and also the demo materials.
Okay, and we also, just to let you know, we do have, so after all this event is done, if presenter is ready to share their slide and all, we do have a location on Power Platform Bootcamp where we'll be storing all the information and all. So if you want to send me also, I will be able to upload.
Okay, thank you very much. Appreciate it.
Okay. So if there is no question, I want to ask question. It's
Sure.
about the measures versus calculated column. So which, yeah, I don't know. In between, I was jumping between two meetings that two tracks that are going on. But have you answered that? And if not, if you can explain.
So in one of the examples I showed, it's a case from, so having it in a measure is more dynamic and flexible. And if you do it as a calculated column, then it will depend on the context that you have in each of the rows, because you are pre-calculating it at a table level, right? So you don't have it automatically calculated according to the context that is being changed. So my recommendation is, if you needed to display it as a dimension for someone to use it as a filter, put it in a calculated column. If you don't need it, the simple answer is a measure.
Okay.
I have a question for you, Pedro.
Sure, Ashraf.
Yeah. So if you have if you want to do a calculated column and you have the two options, whether to do that in DAX or M in Power Query, which one do you prefer and why?
So it usually the typical BI guy answer, it depends, But the normal case in 70 or 80% of the cases for calculated columns, it's better to do it directly in Power Query, because then it will not consume memory. It will be pre-calculated once and stored into your model. It also depends, of course, if you are doing this in import mode or in direct query mode on your model or in composite model. But the best, usually the best way is if you are working on import, do it in Power Query for calculated columns.
Awesome.
What is the good use case scenario for calculated table?
For calculated table, if you want to display some data, not like I did in one of the examples, but to display it permanently for the users to access just a summarization. If I didn't want to show just how many categories have over 200 products, but I want to show a table with some statistics and metrics for these products, and I want to be able for the users to be able to export it. So that could be a use scenario for that.
Mm-hmm. Okay. Any question, anybody? So, Pedro, you have shown some resources you were displaying. If you go back to that slide,
Yeah, sure.
for somebody who is very new to DAX, like you have a DAX guide, all those SQL BI, they have written very good book. But if somebody is just getting into DAX, right, what is the best way for them to learn DAX?
I recommend two things. One is in this site SQL BI, there is a free course on DAX, an introduction to DAX. It's still one of the only courses that is free there. And the second thing is with the Microsoft Learn documentation about DAX too. So you search for Microsoft Learn DAX and you'll find too.
Microsoft Learn and DAX, right?
Yes.
I'm going to put that link in a chat window if anybody is interested.
Do you mind, Pedro, if you quickly share DAX.do?
No, not at all. I think I have it here. Yeah, it's this site.
Yes.
So this is brand new. It was just announced, I think, 2 or 3 days ago, and you will be able to do some analytics and to try it out some code here. I haven't yet tested it, but I've seen it and I'm looking forward to test it, especially for some classrooms or for some assessments. I think it can be quite interesting.
So those tables on the left are preloaded already, pre-populated.
Yeah. So it's like you have a model here for just with a data set. I think that in the future they plan to put a few others here.
But you cannot upload your own model, for example.
I don't think so. Think so. No. But it's quite interesting to do DAX in the browser, right? And to test the code. I think this looks really a cool product for sure.
So those tables are coming from like Contoso, AdventureWorks. Like, what is the source for those tables? Do you have any clue?
So the Contoso is one of the models in which the SQL BI guys usually do their courses and the material on. Yeah.
Okay, yeah. And the other one is?
So these all are in the same model, in the Contoso model.
Okay, the drop down and Contoso.
Yeah, this is just different metrics in the model and things like that.
But the drop down list that has Contoso, does it have any other option? Oh.
No, I think it's just something, I don't know. I hadn't even checked this one.
Okay. Cool.
Something definitely to explore. So if you want to hear a bit more, I think we'll do a meetup on Power BI Portugal. It will be in English, and I'll do an interview of the Marco Russo and Alberto Ferrari, and I'm looking forward to ask them some questions about this.
Do you mind if you share the link with the group here?
No, not at all. So if you search meetup. Power BI Portugal. So you'll find here, you put our events here, and the next one is this one here.
Can you put it in a chat window, please? So if
Sure.
some of the participants, they want to join, they can join.
Here you go. So this one, sometimes we do it in English. Sometimes we do it in Portuguese. This one will definitely be in English.
Okay. So with that, we are at the top of the hour, and our next presenter is Ashraf. So thank you so much, Pedro. We learned so much, and there are so many things what you explain. It is yet to come. So there are many more things to learn from that as well. And thanks for sharing the meetup link, because when you talk about DAX, Marco Russo is the topmost guru. So it's always pleasure to actually listen to him, because he was in Toronto. Actually, he presented at our user group 3 years back, and I think it was 150 people attended, and then Alberto also came here and he presented as well. So it's something that uh, everybody is looking for. So thank you so much for sharing, and
So
thanks for a
my pleasure.
presentation.
My pleasure. Thank you very much for having me, and have a rest of a good day, everyone. Thank you very much.
Thanks, Pedro. That was very informative.